in this example right here, we are being required to find the effective resistance for these resistors R1, R2, and R3, and the key thing here is that they are put in series. So if we are to draw a sketch, we have this resistor right there, 3 ohms, it's in series with another resistor here, 6 ohms, and another resistor right there, 4 ohms. Now, one thing we know about resistors in series is that they will have the same current going through them. So, to find the effective resistance of this in series resistance is going to be R1 plus R2 plus R3. And definitely our R1 is 3 ohms plus R2, which is 6 ohms, plus R3, which is 4 ohms. And our effective resistance right there will be 13 ohms. Right here we're having that if a current of 3 amperes is passing through the series combination, find the potential difference across this resistor. Now in our previous number, this is what we had done. Of course, if I am to redraw the sketch I drew in the previous number, so the question says that the current going through here is 3 amperes, going through all these 3 resistors. So what's the potential difference across each resistor? We know that the potential difference across, so meaning they want the potential difference across this, they want the potential difference across that resistor, and they also want the potential difference across that resistor. So we know that to find the potential difference V is going to be equal to current I times R. So let's call this our resistor 1, resistor 2, resistor 3. So to find the potential difference across resistor 1, V1 is going to be the current going through that resistor, which is 3 amperes, times the resistance, which is 3. And definitely 3 times 3 is 9, so that is 9 volts. So that's the potential difference across the 3 ohm resistor. Getting to the potential difference across the 6 ohm resistor, V2 is going to be equal to the current going through the 6 ohm resistor, which is 3 amperes, times the resistor itself, which is 6. Of course, 3 6 are 18, so we have 18 volts. That's the potential difference across that resistor. Then, finally, to get our V3, we know voltage is going to be current times resistance. So the amount of current going through the 4 ohm resistor is still 3 times the resistance, which is 4, and definitely this is going to give us 12 volts. So 12 volts is the potential difference across the 4 ohm resistor. Now in this question we're being told that if the current going through the resistors above is 6 amperes, what is the total potential difference across AB? Now this is a conductor, the current going through this is 6 amperes. So we are having 6 ampere going through here, and it is the same 6 amperes going through right there. So to get the potential difference across AB, meaning that we want the potential difference across AB, we are going to get the potential difference across the 3 ohm resistor plus the potential difference across the 6 ohm resistor. When we add these two potential differences, then we are able to get the total potential difference across AB, just like the question requires. So to get the potential difference V across AB will be equal to, we are supposed to get the potential difference V across the 3 ohm resistor plus the potential difference across the 6 ohm resistor. The potential difference across the 3 ohm resistor is going to be, of course, the current going through the 3 ohm resistor times the resistance plus the current going through the 6 ohm resistor times the resistance, because we all know that V is equal to IR from Ohm's law. So this is going to be equal to the current going through here, which is 6, times the resistance, here it is 3, plus the current going through the 6 ohm resistor, which is still 6 amperes, multiply that by the resistance, which is 6 ohms. And definitely 6 times 3 is 18 plus 36, and we shall end up with In a circuit here, we are being required to find the total resistance and therefore the total current in the circuit. So let's first find the total resistance. This is a dry cell right here. It is giving off current. Now when you look at current going through, because this is a dry cell, so the kind of current it's producing, the current going through the 3 ohm resistor is going to be the same current going through the 2 ohm resistor. It's going to be the same current going to go through this other 2 ohm resistor, and this current will be coming back here. So what does this mean? It means that these 3 resistors are in series with each other because we are having the same amount of current going through them. So now to find the effective resistance in this circuit, the effective resistance are, because that's what the question first wants us to get, effective resistance is going to be 3 plus 2 plus 2, which is 7 ohms. That's the effective resistance of these resistors in series. Then thereafter we're being told to find the total current in the circuit. Now we know that from Ohm's law, we know that V is going to be equal to I times R. And our voltage, according to the question, our voltage is 14 volts. Now this 14 volts is the electromotive force or the EMF of this cell. It means that the total current, it means that the total voltage in this whole circuit is 14 volts. So it's going to be 14 volts is going to be equal to the current going through this whole circuit, which we are looking for. Multiply that by the resistance, the effective resistance in this circuit, which we got previously as 7. When we divide both sides by 7, we shall end up with our current as 14 divided by 7, which is 2 amperes.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Kuramia helping you manifest excellence.